Thank you all for coming. This is a session about how to connect third-party data into ArcGIS, specifically using an open source library called Coop. My name is Daniel Fenton. I'm a software engineer in the Washington, D.C. R&D Center. And I'm the maintainer of Coop. So before I dive into the slides, I kind of want to just show you a demo that kind of illustrates the power of Coop. So for example, say I want to get data from here in Google Sheets. It's an environment where I'm collaborating with some colleagues to collect data, and I still need to be able to visualize it in ArcGIS Online. Because I've created what's called a provider in the lingo of Coop for Google Sheets, I'm able to connect that data. So I can start my Node server here, and Coop is a JavaScript library. Runs on Node.js in the server. Take this special link here, and this is just pointing at my local host and putting in some key parameters, like which Google Sheet is it, where in that sheet is the data located. And now what I'm essentially doing is tricking the ArcGIS platform into thinking this is a feature service. Let that load up. What have I done? Correct my error. So I've got data on the map. Why not just create a table service for that, or use some of the built-in ArcGIS tools? It's because then I can use some of the live editing capabilities of Google Sheets. So actually, let me turn on refresh for this layer. And pretend like I'm actually live editing. I'm really just kind of a contrived example, but Google Sheets Provider was actually used during the Hurricane Harvey response by FEMA. They had volunteers collecting data about people's locations, what their status was, and they were all collaborating around this Google Sheet. This kind of sprung up naturally. FEMA needed to see it in their dashboards and be able to task resources. So now that I've pasted that data in, my demo works the way I want it to. We're going to have we'll just reload the layer. Oops. Sorry about that. Not my smoothest demo, but I just made this one up. I wanted to have something fresh. There we go. So we're starting to load other data in. Let's go back and now just talk about a little bit of the background for Coop. So I like not to assume too much about everybody, so just some kind of the basics here. When we say Coop is an open source specification, an open source implementation of the Geo Services specification. That's a fancy way of saying that it speaks the same language as ArcGIS feature servers. And that is an open specification, and that's how we've implemented it. It runs on Node.js, and that is a JavaScript runtime for the server. So same JavaScript that you'd use in your browser, plus some packages run on the server. It is packaged with NPM. That's just the Node package manager, website npm.js, where most packages get placed. That's where you can download the different versions of Coop. And it's Apache licensed, so all the components in Coop is made up of several individual libraries that work together. All the components are freely reusable. You can use it for commercial, whatever. Change the code. Please do contribute back. And it's styled Coop in lowercase, not all uppercase. I don't know where all the uppercase came from, but it's going around, and I'll just kind of whittle away at that. So just the conceptual architecture, and I wish this would go away. There we go. No? That's not going to go away. All right. So as I mentioned, there are providers. Something I didn't tell you about are outputs, and then you kind of have the Coop server in the middle that is gluing things together. So a provider is something that talks to the third-party API. It speaks the language of that API. In the demo that I showed you, we were speaking the language of the Google Sheets API. So the provider's job is to fetch data from there and give it to Coop, and Coop will kind of do the rest when it comes to outputting that data in Geo Services. There are several providers that exist today. You can check them out in the Coop repo, things like Google Sheets, Fusion Tables, Yelp, MarkLogic, GitHub. It's been kind of an explosion of providers lately because it's easy to just implement a single function. The provider only needs to know about the source data. So when should you actually use Coop? Definitely not when it's really easy for you to use a feature server, right? The data doesn't exist before. Coop is the tool in your toolkit when the data is sticky, and I mean it's already heavily used in business processes. It's got its own schemas, and it's not something that you are able to migrate to ArcGIS Online or ArcGIS Server. There's no SDE connection already. That's when you should use Coop. If you want to use the data across the ArcGIS toolkit, so you want to use it in Insights, you want to use it in the map viewer, web app builder, etc., that's a good time to use Coop. If you just have a custom app that just needs to read this data source, you don't need to implement Coop for that. It's also useful when someone else controls the data. So it's a subscription API, for example, Yelp. Makes their API available. You can't get all the data, so you kind of have to just work with what's there. Coop is able to be a translator. Some of the users today, and we're hearing new use cases all the time. Got kind of county GIS departments that are wrangling data that they subscribe to, or maybe come from other systems. Cities working with their 311 data. Talked to a couple customers in the energy industry and federal government who are enabling data that's stored in Elasticsearch, which is really cool. So they're able to work with large data sets that are kind of already used for existing business processes while they're not in the spatio-temporal data store. So they're able to just take the data where it is, get it into ArcGIS Online, do interesting aggregations and queries. And we've now got kind of a set of database providers who are starting to build Coop in so that they can connect their data stores to ArcGIS Online, and the ArcGIS platform, excuse me. MarkLogic is a great example of that. They've open sourced their provider. They kind of built Coop deep down into it and let their database do kind of what it does best in terms of full text search and querying and graph searches, and they just expose that through Coop. And then the ArcGIS Hub team uses Coop to power our download system. So we're ingesting data from 100,000 different feature services and outputting KML and CSV and shapefile, all using Coop. So I told you about providers, but there are several other types of plugins that make up Coop. The core of Coop is really just a few hacks and glue to make it really easy for you to write providers and outputs. So that's where the plugins are really the interesting part and make up a pretty good extensibility story. So you got providers, their job is to translate remote APIs. They fetch the data, translate it into Geo JSON, hand it to Coop, and Coop does the feature server routing and serialization from there. You've got output providers, and their job is to kind of be that API interface. So the Geo Services output provider is what does the magic to make feature services come out of Coop. We've got cache plugins, and cache is useful if you are able to actually store all the data in memory. Say it's a flat file, and you can pull it onto your, all into memory. We've got the memory cache, which is by default enabled in Coop, and then you can use the Redis cache if you need a bit more persistent storage, and that's useful for things where configuration settings are saved. For example, you want to be able to share that between multiple nodes, or you just want it to live between restarts. We've got file system plugins, and that, for example, is used by the ArcGIS Hub download team. We use a file system that is actually backed by S3. We can use the same kind of node streaming, file reading, and writing with this file system plugin. And then you can really extend the Coop API in any way. So there's a general plugin function. One of the ones that we've created is a reverse geocoder. So really, kind of the sky's the limit there. You can extend Coop in any way, but we've also got these kind of specific areas where there's an API pattern that you follow. All right, so I want to get a bit more deep into providers. So these are where you translate from remote API, and you end up with Geo Services or WFS. There are two major types, and I'll show you examples of both. There's pass-through providers, and those are ones where you are communicating with the remote on every request. So you're not holding on to any data. Just every time a request comes in from like the map viewer or ArcGIS Pro to the feature service, actually going out, fetching data, doing the translation, handing it back to Coop every time. So use that when the data is really large. So for example, if you've got a billion records in Elasticsearch, you're not going to want to load that all into memory to serve a single feature service tile. That's when you use a pass-through provider. Or the API is really capable. So it supports filters, geometry queries, aggregations. You can also kind of have a halfway blend where the provider supports certain things like geometry, but it might not support kind of SQL-style where queries. In that case, you can kind of let the provider do what it does and then do post-processing with Coop. So to kind of make sure that whatever the capabilities are of the underlying service, you end up with the right response to a feature service call. So whether that it needs to run out statistics or it needs to do a further, more precise geographic query, Coop is set up so you can really have a really, really dumb provider, like a cached one that is just a single file, for example, like the GitHub gist provider. Right? You can just load the whole gist at once into memory. There's no capabilities at the end of that API. It's just a link to a flat file. Or there is an API, but the data is small and it doesn't change very often. Right? That's a good time to just bring all of the data into memory, let Coop hold on to it, and do all of the where queries, geometry aggregations there. So let me just show you some quick examples of providers. So this one is just the Coop provider sample. It's based off of the Portland TriMet provider, which is Portland TriMet is their bus service. And they have an API that, in their own way, responds with the locations of buses live. Your providers implement this key function called GetData. This is as simple as a provider can be. You implement one function in a file called model.js, and it's called GetData. And its job is, well, to get data. So it is passed in the request, and Coop uses the Express.js HTTP server, so the request is that object, if you're familiar with that. Really good documentation on what's in there, but you will get certain parameters that come through. So if you remember that URL that I showed in the beginning, there was the parameter that was, what sheet is it, and then the parameter of where in the sheet. And then you get the query. So the query is, the where clause and a feature server query that filter or a geometry or an out statistics. So in this GetData function, we request data from the TriMet API, plugging in our developer key, which is injected through configuration. Request that data, translate it into Geo JSON, potentially add a TTL, which is short for time to live, or how long should this data be in the cache. So you can use Coop's built-in caching. It'll pull data out of the cache until that TTL expires, and then it'll pull from the provider again. You can fill in additional metadata, like the title of your layer, the description, the geometry type. You can get really detailed here and pass things like time info, exact field metadata, things of that nature. And I'll go through the metadata a little bit later. So the translate function, as I said, its job is to actually make GeoJSON out of whatever that API is returned. It could be literally anything. You just have to make a GeoJSON feature collection. So it's a really simple format. Two main keys here. The type specifies as a feature collection, and then features is an array of GeoJSON features, which look like this. So you've got your type here, which is feature always, your properties, which are a flat set of key values, so like object ID 1, speed 20, and then your geometry, which can be point, polygon, multi-polygon line, multi-line. So what we're doing is we're mapping over this input result set vehicle. I think there's an example here actually of how the provider API, the TriMet API returns data. So we need to get it from here down to here, right? So that's all what's going on in this GeoJSON translate function. And then call back to Coop handing off the GeoJSON null in the first position, meaning there's no error. Right now, Coop does all work in callback styles. We'll be migrating or adding a promise API in the future. So that's the most important part of this provider. As I said, it's a pass-through provider. It's not. It's actually kind of a blend because it is able to hold all the data in memory. When the TTL expires, it can fetch again. So actually, this is a cached provider when we're setting that TTL. If we're not, it actually just becomes a pass-through. But it doesn't support any of the queries. So that's all handled in Coop when you do a filter there, for example. So a couple other key files here. There's only one other one that you actually have to fill in if you're just doing the most basic level of provider. And that's this index file. And it specifies some configuration metadata. So the key things are specify the type, because a provider is just one of many plugin types. You give it a name, and that's important because that's how these URLs are going to get constructed. So you can have a Coop server which has many different providers installed. So everything is namespaced in that first position. You can set which parameters you want. So the host parameters would be the parameter in the first position, and the ID parameters in the second position. And we'll be working on kind of adding additional or named parameters in the future as well. But this works for almost all use cases we found. Or you can kind of jam more information into a single one of those parameters. Point out where the model is, point out the routes, and the version. that was actually, as I said, an example of both. You make it a pass-through or a cache provider. I'll show you kind of a true cache provider with Yelp. So you'll see again, our index file looks about the same. We point out that the model is in a file called Yelp. You can name it model.js or whatever you want. And then we implement a GetData function. Right? This is kind of the minimum that you need to implement. And what this is doing is it's building queries based off of the rec.query object. Again, those are the things that are passed to the feature service that are like where and geometry. So because we can't get all of the Yelp data and put it into memory, we have to play with its API, which means we not only need to translate their response data, but we also need to translate the Geo Services query down to Yelp. So that's what we start in this provider. We build a set of queries, and this one is it's kind of being fancy because you can only get like 20 requests, and so it's making 4, and that's why it gets a little bit more complicated. But at its root, what we're doing is setting a set of parameters that Yelp understands and determining them from the Geo Services query. So the sort, so order by fields, gets translated into a sort parameter at Yelp. The search term gets set as a special parameter in the geometry. So we're passing kind of as much of that query so we can get kind of the closest to the exact search or set of filters that we wanted before applying post-processing. For example, with Yelp, you can search for text, but you can't filter by the types that it returns. So you do kind of this fuzzy search with Yelp, and then Coop will do the applying the actual kind of SQL filter to make sure you get exactly the features that you've filtered for in the API. All right, so just kind of generally, how do I go about writing a provider? First step is, and this is actually backwards because I typically actually try to reverse engineer the API before I even find the API docs. I find that's kind of like the fastest way to understand the calls that clients can make of remote APIs is just crack open dev tools. So for example, in the case of, I made a Craigslist provider. Craigslist. So I was looking for a new apartment for like 3 years, and of course had to, GIS it up and make myself a web map with all of the available, where is my office and where is, I'll just show it to you. So like my beef with all of the apartment sites is that they show you apartments, but they don't show you very well the other things that matter to you, like where are the grocery stores and the restaurants and things like that. So this is a map I've made, which is actually pulling the data live from Craigslist and Yelp to filter down so I can look for 2 bedrooms. And yeah, I said I went all GIS and I had my habitable zone that I can live in, how close to the metro. So, I obviously needed that to make a choice. Hitting Craigslist and Yelp in this provider. Yeah, and I had to kind of show this to make up for that flop of a demo at the beginning. Yes, it actually does work, believe it or not. Yeah, so the restaurants are coming in from Yelp. It's piecing together a couple of queries and getting like the top 40 in the area. Yeah, the apartments are being pulled live. I can go in and I can filter the bedrooms down, and it'll make a request. and filter down, just to the 2 bedrooms. I was able to style and all that. Just the power of the ArcGIS platform to data that doesn't come from ArcGIS. That's the name of the game. So keep looking for Washington in here. Anyways, we'll just look at Palm Springs apartments. So I go in and I look at the client and I start to kind of, they have a map, cool. So they're clustering. How do they do that? If they're putting the data out there, they typically have an API. I go into network and I usually filter down to XHR, look for JSON. And there I get a response, right? And so filter that down and I can see what are they actually returning? And can I just kind of copy or parameterize this URL? API docs are great too, but I find, and often with ArcGIS, it's easiest just to look at the clients and see how they're using it. So I get this URL. And inspect it, and I can see, there's a pattern here, right, to the city, right? So it's Palm Springs first, and I think if I switch this to Washington, D.C., yeah, I get the D.C. ones. So that's how I end up making it work like this. So this is just one that I have deployed, pointing at, kind of any city that you want to plug in, just on a toy server. So I go in, I see what their response is. Get that back. And then I write the GetData function, right? I figure out what the parameters are to get the city I want or the type of thing. I look at what are the individual responses here, right? So this is this kind of deeply nested object, and Coop doesn't need to know, Coop itself doesn't need to know anything about it to make the feature services work for you. This is all your provider, your business logic. How do I fetch the data? How do I transform it into Geo JSON? So each of these you can kind of see, or I can, how this is going to map over, right? I'm going to see that all of these are going to end up being the geojson.properties. I'm going to see that here's my geometry that I can plug in. And so, I just end up translating that data in the model, just looping through and generating, doing type coercion, which would be kind of necessary because, ArcGIS is expecting to be dealing with a relational database underneath, right, that has strict type enforcement. So do type coercion. If I want things to be dates and work with date filters, I need to convert those into what are called ISO strings. Alternatively, I can specify metadata.fields on that GeoJSON, and I'll show you that metadata in a minute. So I coerce kind of all of the types so they're exactly what I want them to be, and make a GeoJSON feature. And so then I end up with /0. So this is just the the f equals JSON view. That's all Coop supports. But you see, it's you just take that format and you move it over, and then Coop will take properties and make them attributes. It'll take GeoJSON style polygons and make them into Esri geometry. The reason we chose GeoJSON is because it works really well with a lot of other open source tools for doing like SQL in memory and things like that. Nothing against Esri JSON. All right, so I go in, I implement GetData, I write a few things in that index. Usually I just fork the sample provider and just change a couple of keys, implement the GetData. It's kind of like an abstract interface if you're coming from the Java world. And then I launch my server, and then I have the data in for me these days, if it's a pretty simple API, it can be a few hours to whip together a provider. And then the long tail is, of course, enabling additional features like time, or if there needs to be pagination, you need to pass a lot more metadata, you have multiple layers. That's kind of the long tail. But it can be actually really simple. That Craigslist one, it was probably something that I could knock out in an hour, maybe less. Actually, I want to talk a little bit more about, at this point, some of the advanced features of providers. Go back to my sample. So there are a few other files here that I mentioned. There is routes.js, and actually this is a bad example. Let's look at so this is a neat little provider that actually turns like 10 feature services into one by kind of coercing all of the fields into what the actual sources are. So it's Geo Services on top of Geo Services, but it blends, you've got different schemas, and so this has an API that lets you specify kind of how things map into a common schema, and it'll request all the things on the fly based off bounding boxes. You can talk to me more about this one later if you want. I won't go into it too much in detail, but it has some advanced features like routes. So this has additional routes that it wants to handle in its controller. And that is, we're putting these schemas, and it's holding them actually in its Redis cache. It's using an additional feature there. So we can get, put, delete, or post, we're calling a data set to this composite provider. So the format here is you specify the path, the methods that you want to handle, and what the handler function in the controller is. And then this, of course, is the pattern. So this is going to be rec.params.id in the controller. And then another one here, composite ID schema. All of these are going to get set up by Koop itself. You just have to specify the routes here, and Koop will actually make them available for you. And when your server boots up, it'll show you all the routes that you have installed. So here is the controller, and again, you don't have to do this. This is advanced stuff because we're handling additional routes. We're doing more than the GetData. There's something else going on here. So this is the format of a controller. You export an object which takes in a model. And you can then specify those functions that map to the routes in that routes.js file. So in this case, we had the dataset handler and the dataset schema handler, and these are just a wrapper over the model, which is it's typical MVC pattern here, without the V really. But additional functions that are called on the model. So get dataset, put dataset, remove dataset. And those correspond here. So we've got these additional functions. So if you need your provider to handle additional endpoints because you need to configure it with API calls, this is a great way to do it. It's just by extending that routes.js, that controller file, and then in your you'll point to those in your index. So model, routes, controller, controller and model, because you're exporting classes here. All right, so I want to talk briefly about outputs. As I mentioned, Koop is really extensible, and you can create different API interfaces for it. So the Geo Services output is really mature at this point. It does a lot of the feature service spec, like generate renderer, and actually can do projections for you. But there are others out there if you need, compatibility with WFS, like an open layers application, or vector tiles. You can generate those. Those are the WFS and the vector tiles are more experimental. They're part of demos that I put together for FOSS4G. So if anyone wants to pick those up, that would be great. But it kind of shows the pattern of a provider, which is going to look similar with these route files. Look at the Coop Provider, Geo Services, Coop output. We have this naming pattern: Coop output, Coop Provider, Coop plugin, Coop file system. So this exposes routes in the same way as that routes.js file. So feature server layer method, feature server layers. These end up getting kind of tacked on the end of your provider URLs. So we end up with /Google Sheets and then the parameters that it specifies, and then this gets plopped on to the end there. And that's how those they dive down. So when your output is created, it gets the Coop's core model, and this function pull is pulling through Coop's cache. That's why it's named pull. But it eventually calls GetData here. So you can call this .model.pull in your output, and it will reach through getting data out of the cache if it's still fresh within the TTL, or actually driving down and calling GetData from the provider itself. And then this one, it's actually all of the code for feature service routing. And actually handling them is in a different repository. So this looks kind of simple. There's a lot more kind of logic to writing a provider, or an output. So I mentioned a minute ago that I wanted to show you the metadata. We're in the process of collecting these docs better, but if you want to see kind of the full way that you can extend your provider to provide additional information, this is the page to look at, the doc to look at. So with these kind of pass-through or more advanced providers, the pattern is you're going to end up providing a lot more information or different types of responses. You've got your typical features response, but if your provider knows how to handle out statistics, so like running the variance on a field or the mean on a field or set of fields and doing group bys, you can actually respond with those statistics, and Coop will then render the results. So you don't have to fetch all the data and let Coop do the statistics in memory. You can be more efficient, pass that down because your third-party data source has that capability. And there is a ton of metadata that you can add. So the name, the description, the extent. So just use the extent by arrays. You can set your display field, geometry type, what the object ID field is. And if there is an ID field, that's really useful, especially if it's an integer. It just makes things smoother to work with. All the ArcGIS products when you have an object ID field. As I said, you can specify time info. You can pass all the fields. And this is actually really useful because if you do not pass this along, Coop will infer your types. And while that works most of the time, sometimes if you have like undefined responses in some of your fields, Coop won't always be able to infer what the correct type is. So you just pass this set where you have the name, the type, and the alias for each field, and Coop will use that in the feature server info metadata type requests. And then this down here is the filters applied. So this is kind of a shortcutting mechanism for Coop's post-processing. So if you are able to handle geometry at the provider itself, you don't need Coop to do it, and you don't want Coop to loop over the data and try to do it, then you can set geometry, filters applied.geometry to true. Same for where, the where clause, if you've already offset the set of results, so you've paginated 100 down, you don't need Coop to do that for you, or if you've already projected your data. So all of these are kind of performance hints, essentially. You tell Coop this is already done, and it skips a loop, you get a faster response. And then the count. So if you want to respond directly to return count only equals true filters or parameters, you can do that. You don't have to fetch all the data and then like Coop count it up in memory. So you can kind of really push all of the work down. You can also pass in the statistics objects, and I think we have some examples down here, class breaks. See if we have the statistics. I have to improve those documentations, but you can also do like Jinx natural breaks and pass those up. Cool. So I want to talk a little bit about deployment styles and their benefits. The number one easiest way to deploy a Coop app is with the Now CLI from Zeit.co. That's their website. You can give it like a server.js and just type Now, and it will upload it to the cloud. Now that's all public, but it's a really great way to be able to do to share an idea or do debugging. A lot of the stuff I do is public, so I like to use Now. It's super, super great tool. If you have access to AWS and you're comfortable with the tooling there, Lambda is an awesome way to deploy Coop apps. You can have configuration. You can use authentication from the AWS API gateway, kind of layer all that on. And not actually worry about deploying your server. So that gives you, you can set environmental variables, which means you can plug in configuration keys that you wouldn't want to put into a public instance like Now. I love doing these Lambda deployments using a CLI called Claudia.js. And if you look at the sample provider and a lot of the other new ones that have come up, they have instructions for how to deploy with Lambda. There's some setup involved, and there are some drawbacks. But for example, Hurricane Harvey, we had no idea how much load there was going to be on this provider that we set up for Google Sheets. So we put it on Lambda, literally never worried about it, right? Because it was hitting the Google Sheets API. All we had to do was look at and see that our rate limit wasn't exceeded for Google Sheets, which it wasn't. And we didn't have to worry about scaling or operating or whatever. So I love those Lambda deployments. We use Kubernetes to deploy Coop in ArcGIS Hub. There is a Kubernetes example. If you look in the main Coop repo, you'll find links to all samples and examples. And Kubernetes works great as well if you need kind of low latency. You need it to connect into other resources that you may have in AWS or talk to other services if you have a cluster going. We've loved doing it with Kubernetes, the auto scaling, the easy deployments. It's been great. And then if you've got, if you're running it locally, you can use, you could write like systemd or the Windows equivalent, kind of server files to keep these up, or you can use these really easy tools like Forever and PM2. And those are just available on NPM, the package manager that I talked about. You can install these and just say, Forever run server.js, and you can keep it up locally. Now, if you are running Coop locally, that can be useful if it's on your own network and it's data that you don't want to share publicly, but you also don't want to put auth in front of, because the auth picture is kind of a DIY right now. It is on our roadmap to at least do proof of concepts. People have done auth with Coop, but right now it's DIY. But you can run it on your local network, kind of behind the firewall, kind of share data in that way. Things you'll probably have to do there are set up DNS or pass around an IP address. Make sure that it can reach the APIs on the outside network that you want it to, for example. So just to talk a little bit about the roadmap. I'm very excited. We have hired an engineer starting Monday who's going to own Coop full time. I've been kind of doing it as a side product, side project, and he's going to be able to own it full time and really dive in and do better docs, bug fixes, especially when it comes to different ArcGIS clients. So making sure it's working in Pro and ArcMap and Web App Builder and pagination. Definitely want to get on those bug fixes. And then as far as new features or new providers, we want to do better support for multiple layers. That's a pattern we've seen emerging with some of our people that are adopting Coop in the corporate or federal space, is that they've got, like Elasticsearch, and they got a ton of indexes, and they don't want to do 50,000 URLs. They want to have feature server /12345, whatever. There are ways to do it in Coop right now, but they're kind of they're cow paths. So we want to pave those over and give kind of specific functions for multiple layers. So it's basic support for auth. That would be actually ArcGIS auth. So it would be as if you federated your server with ArcGIS Portal or ArcGIS Online. And then we'll probably do some strategic providers for the ArcGIS Hub product. So we don't really do providers, or the core development team, we don't take requests for providers. Professional services absolutely will. And they've done this for a number of different customers now. So if you have a data source, but you're not ready, or you're uncomfortable, or don't have the time to implement Coop, our professional services teams have the ability to do that. And then we'll do some strategic ones that are really core to our mission of solving urban problems. So maybe 311 APIs and things like that. I'll just talk really briefly. There's a couple of Lego blocks that I think could be really useful outside of Coop that you might want to think about. One is called Winnow, and I'll let you query Geo JSON without a database. So it's doing SQL and geometry and aggregations. It powers Coop's ability to make your provider look like a feature server, essentially. And that's called Winnow. And then there's Feature Server, which is the open source Geo Services implementation. It's kind of developed outside of Coop because we think that there are other potential ways to adopt and get your data into the Geo Services API without implementing Coop. So that's why that's out there as open source. So resources to look at are the Coop.js organization and main repo on GitHub. There's coopjs.github.io, and that's linked from the main repo. That's our website, docs, and examples. Sample provider is really useful. So like I said, I will typically fork that provider when I'm starting a new project, and the Coop sample app. I just want to show you the actual Coop core repo. So this actually isn't where the NPM package or the Coop package lives. This is collecting kind of all of the different sub-projects. So, and it is a good place to put issues if you're not sure, like, you're not a Coop developer, you're not working on a specific subsystem or a provider. So it'll link out to the core if you want to see what all the different providers are that are kind of supported or semi-supported. You can look in the providers folder and see all the different ones that are in, the different outputs, kind of samples, maybe like crazy things that we're working on, like experiments. So the Polygon geocoder, a UI, Electron UI for Coop that was worked on a while ago. This is a really good place to collaborate. And then kind of the most important documentation is on this site here, and that's the provider specification. So if this is the only thing that you remember, this document and that would be kind of all you need to know how to write a provider, how to do a more advanced one. Kind of condenses a big portion of this talk into a document. So with that, got about 10 minutes left, so I'd like to open it up to any questions that you might have. Saw in the green over here. Uh-huh. I mean, I'd say, like, if a whole request for the data is no more than like 3 to 5 megabytes, you know, it's pretty practical to just fetch it all and like Coop hold it in memory. Or if it's larger, but it doesn't change very often. So if it's, you know, 100 megabytes and it only changes once an hour, or it's 500 and it changes once a day, then it could be pretty practical just to load it in memory and use all of Coop's features. So it's those two things. It's the frequency of change and the size. If it's changing all the time, you know, you're only going to be able to have a short TTL unless you're going to serve stale data. If that's okay, then have a long TTL. So I guess that's the third thing, is how often does it actually need to be refreshed in the client? Yeah. Does that answer your question? Okay. So in the green. Or gray. Okay. Yeah, I think it's the lighting from my angle.
Great. Let's say a person is using ArcGIS Pro natively and wants to make use of this. What is needed to actually connect to this from ArcGIS Pro? And does Esri use any of this already, or any of its services? Is anything built into an ArcGIS Pro already?
So in order to use an ArcGIS Pro, you would just add a layer from the web and use the feature service URL. So you remember at the beginning, I had a constructed URL that looked like a feature server. You can just add that as you would any other feature server URL.
So Coop pretends to be a feature server?
Exactly. Okay. That's all it's doing is it is implementing the same API, so the clients talk to it in the same way they would any other feature server. Now some of our products are using Coop capabilities. Insights is using Coop, and they're kind of packaging parts of it as adapters, but in general, you don't really need to. That's kind of the whole point, is that if you enable the source by making it speak the same API, you don't actually have to do anything special inside any of the clients.
If you add it, does the request come with the extent from the map? If you add it to a map and you're trying to paint a map, the request will come with the extent?
Yes, that's correct. So, and this is a case where if that's important to you, you probably do not want to use the TTL, right? You may need to cache at a different level, or you may actually need to request every time, right? Yeah, exactly. So, yeah, so you get that rec.query object, and the query object is everything after the question mark in the URL string. So that's going to be where equals, you know, speed greater than 50, geometry is this polygon. Yes, so you're going to get those. They're going to be parsed into JavaScript objects, and then you can choose how to construct your request to the underlying API.
Is there a way to assign a custom symbology to your feature server in the provider without overriding like the feature server's default?
Not yet, but that's a good and easy to do feature request.
I've had to basically I just spun up like multiple copies so that I could do custom symbologies for each of my providers. So it would be nice to pass in like a point JSON.
Yeah.
File so that when you drop it in portal or whatever the symbology.
Yeah, I'd like to write that down. Don't leave after. Yeah, send me an email. Yeah. No, that's actually it's pretty easy to add, and that's one of the ways Coop has been growing, is that we've been adding additional metadata, essentially giving you more control at the provider side about how the feature service request is rendered. Default. Yeah, that's hardwired into the feature server package, which is doing the work there. But again, there's no reason that you couldn't just pass one through. Yeah.
From the portal, you can define.
Yeah, you can do it in portal, but if you do it in the Coop provider by overriding the feature server symbology, when you drop the URL in portal, it's
exactly. Yeah.
You don't have to do it.
Yeah. So that's an easy feature request. So yeah, happy to. Yeah, put an issue on GitHub, assign me. Yeah, cool. I think. So The best way right now is local networks, right? So you can only use it within firewall. The other way, which I know it's possible, I know others done it, we do not have documentation yet that we want to have as proof of concepts, is you can actually implement like ArcGIS authentication. So you can say that this is a trusted cross-origin domain. You can have Coop respond on the security response, so rest/info, and say that the owning portal is this one. And then you have middleware that essentially says, checks the token that goes through or responds and says token needed. So yes, it is possible, especially with the ArcGIS authentication. You can see I've been thinking about this lately. That's why it's on our roadmap. But yeah, others have, it has been done. So I know that it is possible. Yeah, it just takes a little development work right now. In the back. Yes. So in my terrible Google Sheets example, that was actually using an API key. So that's in the back. Typically, we use, and if you look at the provider, sample provider, there's a config. We use the npm package called config, and you write out a JSON, and you can either pass an environment to override that, or you can just write it in, deploy it on the server. Yeah, frequently we do that. Mm-hmm.
So with that output feature server,
What's your next?
is there, say like feature server, so users or clients that are consuming it, do they ever need any limitations?
Sure. So I think the most difficult one to deal with is when you have to paginate. So you need more features than it's willing to respond with in one go. That's the toughest one. You see on that Yelp one, I worked around that to an extent by sending 4 parallel queries. Other ways are to paginate and request multiple before you do it. Node is really good at that because you can do this in parallel, do HTTP in parallel, and so the response is only as long as the slowest one. But yeah, typically pagination with rate limiting, then you kind of have to cache, or you have to make sure that you are pushing down as much of the filter as possible to the provider, so you're requesting only the smallest amount.
So I guess is the feature service stack fully implemented in the output?
I'm sorry, did I totally miss your question? It's not fully implemented, but the query endpoint is fully implemented. So to do statistics, generate renderer, so you can do class breaks. That's implemented as well. There are definitely features like editing and other things that are not expected. And yes, sometimes we do get tripped up in the way that different clients talk to it. Those just end up being bugs that we need to fix. So a new feature gets added, for example, and it's making a different type of request that we don't handle yet. It happens sometimes, but yeah, whenever we find a bug, we'll tend to fix it and just issue a release right then. Yeah. He had a question here.
Does it work with non-spatial data?
Yes. So if you pass Geo JSON features that have no geometry, Coop will detect that it's a table, and it'll just do a table service.
The reason why I'm asking is the data which I'm going to provide is not going to have any spatial data. Like, I cannot create a service without a feature class. Like, I cannot publish a with just a one table.
You can do that with Coop. So yeah, it could be your only table, or your only layer would just be a table. Yeah, you can do that. Yeah. I think I have a question over here.
Say so the feature classes and you implement the query aspect. Can you also mock methods where you forward your get image up the server and use something to aggregate everything?
There is not an output for that today. I think it's pretty clear how that one would be written using something like Mapnik, for example, to render the tiles. That would be a new output. So it would be Coop output map server. Doesn't exist today, but absolutely doable. Yeah.
Can you just talk about how you switch to a different type of output?
So yeah, it ends up being by the URL. So those outputs are tacking their specific namespace onto the end of the provider. So you have the provider name and the parameters, and then you have the outputs that just get tacked onto the end. So you end up with like /Craigslist, /Atlanta, /apartments, and then the output namespaces in /feature server /0. The WFS, it's /apartment /WFS. So it just gets tacked. If you're building an output, you set that in the output itself. Property on the output is routes, and that is an array that has the name, the handler, or the path, the handler, and the verbs. So you can see that in the Geo Services, for example, if you want to take a look at it, yeah. Yes, we have done that in the past, where we have done like the cache key based off of that. It can be tricky to get that working right. We've had that in past versions of Coop, and you could extend the cache to do that. Yeah, I have done it. Yeah, it's not the easiest. I mean, caching is a hard problem, and one of the proverbial hard problems. Yeah. All right. Well, thank you very much for attending. If you have any further questions, I'm at the ArcGIS Hub booth for the rest of the day. Please. Thank you.